Hi everyone, today we're going to use our knowledge of trig ratios to find different side lengths. So, I've got a right angle triangle here and we're tasked with finding x. So if we have a look at our angle, this would be our theta, just our given angle. And if we go directly opposite of theta, we're going to get to our opposite side. Okay, we've also got 17 meters here is our hypotenuse, and we know it's our hypotenuse because 1, it's opposite the right angle, but 2, it's also the longest side of the triangle. So hopefully we remember our little acronyms of SO, CA, TOA. We've got in our situation an O and an H. We've got the opposite side and we've got the hypotenuse. So my opposite side here relates to this opposite side here, and my hypotenuse relates to this H here. So we would like to use this SO. So what does that actually stand for? Well, we've got sine of theta equals opposite divided by hypotenuse. Now let's start to sub some values in. So we've still got sine, but instead of theta, we actually know theta is 50 degrees. So we can put 50 degrees in here. Equals, the opposite side is actually our x value, so we can put x in, divided by the hypotenuse, which is 17. Okay, if I multiply that 17 up to the other side, I'll get 17 sine of 50 equals x. Now using a calculator, if it's in degrees mode, 17 times sine of 50 equals 13.02. So x is going to equal 13.02, and the units were in meters. Okay, let's have another example. This time we've got our hypotenuse, we've got our angle theta, but this time we're not dealing with the opposite side, we're dealing with the adjacent side. So if I write out all three of my ratios again, so CA, TOA, I'm looking for the one that contains the A and the H. So the one that contains the A and the H would be my cosine. So we've got cosine of theta equals the adjacent divided by the hypotenuse. Again, let's start to substitute in some values. So this time cosine of 27 equals the adjacent side, which is actually labeled y in the original diagram, so y divided by the hypotenuse, which is 7.9. Okay, same thing, let's multiply up the 7.9. So we'll get 7.9 times cos of 27 equals y. Using my calculator here, 7.9 times cos 27 equals 7.04. So y equals 7.04. And the units were in meters again. Okay, let's look at one more example. Again, I'll start off just by writing my acronyms. I make it nice and easy. This time, we've got the opposite side, which is my z, and we've also got the adjacent side, the one right next to theta, is 46 millimeters. So we need the opposite and the adjacent, which is our tan. So I've got tan of theta, tangent of theta, equals opposite divided by adjacent. Okay, let's add some values in. So tan of 31 equals z divided by 46. Again, let's multiply up the 46. So 46 times tan of 31 equals z. And z equals 46 times tan of 31, 27.64. 27.64. And the units, this time we're in millimeters. Okay, those are a few basic examples of finding unknown side lengths using trig ratios.